All right. See if we get this to work. Excellent. So OpenFlow is a very exciting technology, and it's exciting because it took a control plane, a data control plane, that was fragmented and that was dispersed, and did some great things to it. You know, it was fragmented and dispersed. It was dispersed in the sense that we had many different control planes operating on the network at the same time. We had bridging, forwarding, ACLs, you know, and you can keep on going through the list, multicast and so on, all of these separate control planes operating on the network at the same time. It was dispersed also in the sense that most of these protocols were implemented as distributed protocols. And so you could go to various devices in the network and you wouldn't find a complete, you know, instance of that protocol. You'd find a portion of it. And even if you did go to one of the devices and look down inside of it, and a device in the network and looked at it, what you'd find is inside, flow control was fragmented inside also. We had ACLs, we had QoS, we had call-based routing, call forwarding. You know, you go down to the list of different things that you could configure on a switch, but you configure them out each maybe somewhat differently from each other. And so what OpenFlow did, and what it allowed us to do, is to consolidate the flow control into a single API. It also is it complements existing technologies for discovery, for management, for monitoring, and so on. And then finally what it did was it enabled us to centralize this flow control, you know, into a controller if we liked. And there's a lot of applications for this technology. There's certainly, you know, we can use it, we've heard about it, we can use it in research, we can use it in campus LANs, we can use it in traditional data centers and public and private cloud, service provider networks, and so on. A lot of opportunities for it. What I'm going to focus on today are two topics. One is talk a little about the research and what we've been doing in terms of enabling research with OpenFlow. And then the second is to talk about campus LANs. And, you know, why did, you know, as I was director of research about 4 years ago, and, you know, why was I interested in OpenFlow? And there were two reasons. One was I thought it was an opportunity to learn something about networking that hadn't been done before. What can we do with this idea, this raw idea? And the second was, could we use it to enable research to come up with other ideas for networking? So really to kind of foster an environment where we can get more research, especially with respect to campus LANs, because it's kind of my favorite topic. And so in 2007, started with Nick and Martine, and started talking about OpenFlow. And by 2008, we had an OpenFlow switch implementation. We had downloaded it at SIGCOM. And this was all through a lot of work with people in HP Labs. And then we went through a couple of years of doing some really good research internally in HP Labs around how we could apply OpenFlow to problems in various areas. You know, HP is involved in all those areas. I listed, you know, the data centers and campus LANs and whatnot. And so we had a lot of research going on there. At the same time, the key thing we want to do is to enable research outside of HP. And so what we've done, and what we did then at the time, was to create an OpenFlow-enabled switch that we would offer then to researchers for them to create their own ideas and innovate within networking. And currently we have on the order of 60 deployments worldwide. A little map there showing you kind of where these deployments are across the world. And so, you know, I think there's a lot of excitement, and certainly a lot of excitement for me around how much we've been able to help in terms of enabling research, and I look forward to all the results. And in fact, I was very impressed with those results presented this morning by the researchers, and I continue to look forward for more results in the area. About a couple of weeks ago, I did a survey and asked these people using our equipment, you know, about their experiences with it. I wanted to share a couple things that I learned in that. The first thing is that most of the deployments currently are test beds. They're not production networks. There are a few production networks in the mix, but 97% are test beds. And the second thing is that there was basically an even split around whether they're using the switch as a pure OpenFlow switch or whether they're using the switch as a hybrid switch. A hybrid switch being a switch that you're using both the kind of traditional protocols or features in the switch in addition to OpenFlow, you know, using concurrently. Then I asked a couple of questions. I'm going to share just two of them with you now. And the first one was, what's missing from OpenFlow? You know, what would you like to add to the protocol? And that's the capabilities missing listed here. And you know, and as I looked at that, I thought, well, this is good. You know, really what the focus is on is around expanding that match action pair. You know, making it richer, being able to match on more things, being able to take actions on more aspects of things. And there was also a comment about fault tolerance and scalability, which I think really, you know, something about how the switches interact with controllers and whether there needs to be something specification. I think that's where that came from. The other question, another question that I presented here for you that I asked was, what were the problems that you encountered when you were deploying an OpenFlow network in your test bed? And as I looked at the answers to that question, there were the kind of things that actually I thought were good. It was really, there's a focus around, you know, getting it to work. There's some loop avoidance with non-hybrid switches. Well, that's because, you know, their engineering isn't quite there in terms of the controller, you know, creating a loop repattern or benchmarking for release. These are kind of engineering things where we're figuring out, what do I need to do to really qualify my controller and make sure that it works? And certainly troubleshooting and things of that nature. So there really were around kind of engineering aspects that I think we need to iron out. But I think it's good to see some good focus and progress in terms of using OpenFlow in the test bed and coming up with new ideas. So what I want to do now is to switch and talk about campus LANs, because I think this is the topic of this panel here, and how those can benefit from OpenFlow technology. And first, I think we need to start with what are the challenges of a campus LAN. What do I mean by campus LAN? It certainly is a campus LAN like the one that David talked about in Indiana, which is a large campus LAN. There's also smaller campus LANs, maybe the school district campus LAN that maybe your children you know, attend a school in a school district that's small on that order. So there's a range of sizes and scales for campus LANs. But there are some challenges that each of these campus LANs are facing. The first one is that there is a greater diversity of users now than there were before. Network operators would like to allow partners or visitors to be able to use the network while they're visiting the campus LAN. There's a fragmented perimeter where, you know, people are starting to bring their personal devices to work and expect them to work to be able to operate within that network. And so at this point, the network administrator doesn't necessarily, you know, have control over those devices that the users are using. They'll be connecting via wireless more and more today. Many new personal devices don't even have an Ethernet jack on them. And so you really are going to connect wirelessly with those devices. And then there's various other, you know, inputs and outputs in terms of using the internet or using cloud services. And so this perimeter is being fragmented for the enterprise network. And then the third thing is that there are new services being introduced. These services could be video conferencing or voice over IP and things like that have, you know, maybe different attributes or requirements than what previous applications had. It's not just the database in the back end. There's actually more going on in the network, and these new applications of the network have different requirements. And so how do we deal with that? And the end result is that what happens for a network administrator is that things are a lot more complex. And with that complexity comes great risk that the network may not work and may not deliver the service that the company needs. And so what are we doing about that? Well, what we've done is we've created an architecture, and I think that you'll actually see some similarities to other ideas that have been presented earlier in the day, because I think there's a lot of minds that are thinking similar things here. An architecture that has an infrastructure layer at the bottom. These are the switches, the routers, the access points, the security and application services. A control plane in the center, and the purpose of that control plane is to abstract or to virtualize that underlying infrastructure and present up a virtual network upon which a virtual service networks, as we call them, run on top of this virtualized network. And I've got a slide here that's going to show an analogy. No analogies are perfect, but I hope this one will help kind of elucidate the idea here. And the analogy is with server virtualization. So on the right, you'll see this little diagram, analogy with server virtualization. And at the bottom, we have a server. We have a CPU, the memory, and so on, those components and infrastructure, if you will, of the server. And then on top of that, we've layered a hypervisor. And then on top of that, we've placed virtual machines. And each of those virtual machines think that they're running on their own server. I've got my own server below me. The hypervisors provide that illusion that each virtual machine is running on its own server. And then we have some management software on top of that that helps orchestrate that all together. Now, if you translate that, if you bring that over to networking, what does that mean? What that means is you've got a physical network infrastructure below. That's like the CPU and memory. Instead, in our case, it's switches and routers and APs and so on. And then we have a control plane, similar to a hypervisor, that's going to virtualize those resources and present up a virtualized switching network. And then on top of that, we're going to place virtual service networks, which can be logical purpose-built networks for a specific application or set of applications. And we can layer those on top, and of course on top of the management application and orchestrate all this together. What this allows us to do is reduce the complexity of managing a network by allowing us to set policies at a high level to create those virtual service networks, which are essentially policy statements. And that is translated down into device configurations through this virtualization layer. And when we decouple the physical from the logical, we get a lot of power. We get power in the sense that we can change the physical infrastructure and not need to change our policies. Or likewise, we could change our policies without having to change our physical infrastructure below. We've decoupled the two, and we've enabled some power that we haven't had previously. And this is the application that we're looking at for really taking advantage of SDN and OpenFlow technology. Of course, the connection between the control plane and the physical infrastructure is, of course, would use OpenFlow technology in it. I just had a few closing comments. And the key idea here is that as OpenFlow evolves, as SDN evolves, we need to make sure that it remains relevant. And I mentioned hybrid switches earlier, and one of the issues that we'll have in terms of campus LANs is that enterprise customers, campus LAN network administrators won't tolerate a forklift upgrade. They're going to go replace all of their equipment. Unfortunately, we can evolve and move towards a SDN technology and provide that into these customers through an incremental way. I talked earlier about how we've got these different control planes operating on the network at the same time. L2, L3, ACLs, and so on. And what we can do with a hybrid switch is we can start to pull in some of those various control planes into one and start centralizing them. We don't need to bring them all in at once, but we can start bringing in the important ones initially and start folding in those more and more to where we get a better solution, reducing complexity through bringing those into the control. And then at some point, we can make a shift where actually it is all OpenFlow control and SDN. But in the meantime, we've been able to allow customers to evolve and to migrate towards this model without requiring them to do a forklift upgrade on their network. And the key things involved with the OpenFlow protocol is that we need hybrid switches. Of course, we have today in a forward normal operation. That action is a key thing that we need in the standard. All right, so that's the presentation. Thank you.
Questions for Charles?
Eric? Yeah? That's Eric Hansen on the 451 group. Device support is great, and we're moving forward in a lot of that, but a lot of what we talked about this morning, and especially given this is the enterprise panel, the piece that starts to complete this is management. Where do you see that happening, and which parts of that do you see HP heading at?
So I described those three layers, the infrastructure layer, the control plane or control layer, and the management layer. And HP has products, of course, that fit in all three of those categories today, right? And so our plan is to evolve those products to use SDN and OpenFlow technology, and thereby, create a better solution. So I'm not sure exactly what your question is getting at. We've got a management application, IMC, for networking, and it will be a management application that will fit into our solution space.
Well, mostly just been talking about levels of abstraction and both representations of the network structure, management structures, and play. Different vendors are looking at approaching these in different ways, and we're just sort of curious with your views of slicing and dicing how those problems work.
Okay, yeah. Well, I think one key point that I want to reinforce that I made earlier is that in terms of a conceptual model of how you manage your network from a management perspective, the idea is to be able to create these virtual service networks, these logical purpose-built networks for specific applications, set of applications, right? And to be able to partition, the things that you need to reason about down into, I want to deploy this application, voice over IP, whatever it is, and can I think and reason about that in isolation of these other things that I also need to do, and get that right, and then move on to my next application of interest. Right, so I think part of a key thing that we need to be thinking about is, what is the conceptual model that a network administrator would have as they approach our tools and begin to use them. And I think that's really kind of a key thing with respect to management, I think, is to present that model. There's certainly a lot of experience with using technology where things aren't as transparent as we would like. You begin to learn how to use a system, and you have to build up a conceptual model of what might be happening behind the scenes, but you're never really sure. And then at some point you make a change, and then things break, and you realize you didn't understand what was happening behind. And so we need to be able to present a conceptual model that's very easy to understand and transparent. So I think that's really one of the key focuses that I would like to see the research community work on is developing that management conceptual model, really, that provides that transparency. I think we saw some hints of that earlier today in research presentations. Thank you.
Okay. We could ask a question? Oh, are there other I have a question.
Okay.
Say a little bit more about your experience with hybrid switches. For example, in your hybrid switches, do the OpenFlow part and the conventional part share any resources? To what degree is it just ships passing in the night? How do you do this a step at a time?
Yeah, so certainly the resources are shared within the ship, within the ASICs and the switches. And so there is like any place where you might have multiple controllers, if you will, operating on a shared resource, right? You need to arbitrate and figure out how to use those resources. And that actually is the issue that we have today. When you think about someone using a variety of different features on a switch, whether it's policy-based routing, ACLs, Lillicat's filtering or something like that, all of those features can be using the common resources within a switch. And so the switch now arbitrates between those and figures out who has priority and who gets filled in and who doesn't, right? And I think what happens with OpenFlow is that if we can consolidate into a single API, that's a good first step. We still have a prioritization problem, but we can start consolidating. So in a hybrid switch, to answer your question, you do share resources, and you do need to deal with that conflict. But I mentioned earlier about how we've got, L2 control happening on the network, and L3 control, and ACLs, and multicast, and so on. All these things actually are operating on the network at the same time today, before OpenFlow, right? And so we actually have a number of controllers. They have to be distributed, in the various control protocols, but we do have a number of controllers, if you will, on the network. And I think what OpenFlow allows us to do is to consolidate that number down to a smaller number, right? And a hybrid switch can start bringing in those control planes, right, into one. And they may not all be included at the same time, but you can start working in and reducing the complexity.
Okay, thank you. Yes?
That's okay. Derek Silva from Infotech Research Group. The 60 or so deployments that you have out right now, great spread geography-wise, which is good to know in terms of the demographics. It looked like a decent spread. But what about size? presumably not very many small businesses, but is there a decent spread between medium and large enterprises, or is it primarily your large enterprise customers that are interested in this and piloting it right now?
The majority of the deployments so far have been for research purposes. So I mentioned that a couple of them were production, but the majority are test beds. Some of those customers are higher education customers, some of them are commercial research, some of them are startups, so it's kind of that mixture. And so generally what we see is smaller deployments. They're not large, 20 switches, 40 switches on that order.
But the actual organizations testing them right now, are they, like you mentioned some startups in there, so obviously they would be smaller, but
There's some very large enterprises, or very large, actually, commercial research entities that are working at overflow using.
Thanks.
Yes. So it really does range though, because you have low end, or I should say smaller deployments, but there are some large ones.
Very good. Thank you, Charles.